Hi everyone, we're Avery and Eugenia, and we teamed up to see whether background music has any effect on Sudoku completion times.
So, when you look around any workplace or school today, you see students and professionals listening to music while completing their tasks. People say that this helps them focus, helps enhance their productivity, but schools have started taking away personal devices to reduce distractions and help students focus better. So, it's important to understand quantitatively and qualitatively with data the effect of music on performance. And in this case, we're using Sudoku puzzles as the analog for any task you complete at school or work. The future benefits of this include that the research can help guide schools and workplaces with their future headphone and music policy. Our research answers the very simple question: does background music result in quicker completion times for Sudoku puzzles? This is an analog for the broader question: does background music aid in work productivity? So there's two hypotheses here. The null hypothesis says background music has no effect on Sudoku puzzle completion time or accuracy. The alternative hypothesis says background music significantly affects Sudoku puzzle completion time and accuracy. The experimental design here was very simple. There were two participants, me and Eugenia. We each completed 10 Sudoku easy level games, and these were completed twice for each puzzle, once with music, once without. This required a music listening device, such as a phone or headphones, and also a quiet room so the run in silence can truly be a control in true silence. The independent variables were music on versus off. In the puzzle, the dependent variables were the correctness as well as the completion time. The data was recorded in a spreadsheet. This is deliberately paired, so the same puzzle is completed once with music and once without, and this data was saved to the CSV to be handled and cleaned. In data cleaning, there were three main issues to fix: capitalization, missing values, and data type. The participant and condition columns had differing capitalization standards. There were some entries that started with a capital letter, some that started with lowercase letter, so it was important that these were cast to all lowercase. Then for missing values, the correct column was missing some entries when there was a time sec present, which means that the challenge was completed correctly. So what I did from here is any row that was missing a correct value but had a time sec, meaning that there was a completed time recorded, the correct column was autofilled to 1.0 to resolve this issue. And finally, for data type, the correct column is of data type float 64. To change this from a double to an integer, I cast the entire column to integer, which changed the entries from 1.0 to 1.
After cleaning the data in Python, we compared times for the same puzzle solved with and without music. We used a one sample t-test on paired differences, music minus silence, and a paired t-test on participant averages. Both tests check whether music produced a consistent change using a 95% confidence level and Cohen's d for effect size. On average, puzzles took 3 seconds longer with music. The paired difference standard deviation was 11.4 seconds, meaning lots of natural variation. The one sample t-test gave t equaling 1.19, p-value equaling 0.25, Cohen's d 0.27, which imply a small non-significant effect. At the participant level, Avery slowed by 5.9 seconds and I by zero point 0.2 seconds. T equaled 1.07 and p-value was 0.48. In the box plot, you could see that the music box looks higher, but the overlap shows the difference is small relative to the noise. And it just means that we don't have enough evidence to say that music is what caused it. On average, overall background music did not significantly affect Sudoku solving speed. The small effect size means any impact is minimal. The limitations for this experiment are that we had a limited number of participants, which is only two, but we did get 40 paired trials, which is a pretty good amount that is enough for such experiment. We saw minor variation in puzzle difficulty. We only used single music type, which is lo-fi. In the future, if we use different music genres, they could show different effect on the completion times. But that's for the future experiment. We also noticed some individual differences, perhaps that had something to do with personal preferences or maybe a familiarity with Sudoku puzzles. We noticed that Avery slowed down a bit with music by 5.9 seconds on average, and I barely changed. To conclude, p-values in the stats analysis were higher than 0.05, so we failed to reject the null hypothesis, meaning that music did not measurably change the performance. For the two participants, Avery and I, music was basically neutral, neither helpful nor hurtful in terms of focus. In conclusion, we also anticipate that future larger study would be beneficial with more participants, randomized puzzles, as well as different genres of music, so that we could test whether certain music types can make a difference. And to conclude our presentation, here are some of the anticipated questions. Why only two participants? Well, we had time constraints and also small scope design. However, we had 40 trials, which ended up being enough. We used paired tests because same puzzles were solved twice. The data paired within each participant and puzzle. Why Sudoku? Well, Sudoku is a good, controlled, logic based task that requires attention and working memory, and it could be used as analog for other cognitive tasks that people perform on a daily basis. Why lo fi music? Well, we thought that it was probably the most neutral type of music, kind of like elevator music. That could ensure consistency. And then the box plot versus actual findings. The box plot showed that the music had wider area, making some people think potentially that music actually did slow the performance down, the completion times down, but in reality, that was not the case. The mean difference was very small, and the variation as well. So this was visually noticeable, but not statistically significant. Thank you so much.